with students that are part of a particular campus. Typically, they would be individuals that would have varying backgrounds so that they can all contribute to the process. Oops.
I'm sorry.
Is it cubic meters or?
No, not flat.
So it's not like an election.
No.
So it's like 10,000 100 by 100.
No. Round meters. Okay, so basically two parts to this then. One is the assessment of the ecosystem to categorize the species there and so on. We'll take a closer look at that in the future in a few moments. And the other part is to actually use the scientific method to assess something within the ecosystem using at least 3 areas of scientific discipline. They are limited to the tools in the bio box and, of course, in the bonus box. Okay? So, in this particular case, though, did somebody read this off? There is a $500 coupon or budget that they can go spend on their own if they feel like there's something that's a little bit missing here and they'd like to improve the tools that are available to them. And then finally, they put that research material together and they go to a meeting and present. And we'll talk about the process of presentation later in our presentation. Battery must be shot.
So the mission of our project is to employ an integrative approach. Because it's an ecosystem project, it's by nature an integrated moment. Because you have levels, you have connections, you have sub-sciences. So we want to investigate a local ecosystem with a specific resources because each of these aspects is a way to observe and to measure and to learn at depth.
Okay, our project, kind of the overarching goals is that we hope the BioBox Challenge will help students to develop the skills necessary or needed to conduct biological research, and especially integrative biological research, things that include their different classwork. It's a way to develop teamwork, problem-solving, critical thinking, and communication skills among a team of students that may come from slightly different backgrounds in terms of their majors. And also, it's a specific opportunity to define a scientific problem, generate a testable hypothesis, and design and conduct independent research within the framework of a limited scope. So you have a very limited area. You're kind of have very constraints, but from the constraints, students then kind of have to focus. So you really have to work within the plot. And this is, again, an opportunity to learn basic techniques and methods that maybe you got in the lab course, maybe you didn't, but these are ones that are used really commonly in agency level or professional level biological research.
So the basic requirements, we've already touched upon most of them, so I'll just review. Every team receives 2 boxes, one at the beginning and then a surprise bonus box that causes them to be flexible in their approach to the process. At least three items will change every year, and that will provide variability to the project each year. And next. Okay. So the project has to be conducted using only the contents in the box, as Bob mentioned, and otherwise there might be instructions in the box that might say you can use a microscope or something like that if so decided by the organizers. The on-site research takes place in a limited period of time, and we chose that time also based on seasons, so that would be a period of time that most parts of the country would be able to participate. And the study has to be within 3 miles of campus and within that 10,000 square meters, any configuration. So it could be along a stream bed, it could be out in the field, it could be in however, along the coastal areas, so part would be coast, part would be inland, so however we choose.
Okay, the components of the experience for the teams are basically threefold. Ecosystem characterization, as indicated earlier. This would include, to begin with, an inventory of the species within the site, and they could use varying techniques for that, taking samples, plant samples, either pressing them, taking pictures. If they take pictures, of course, the plant samples, if they take them, they probably couldn't bring them here for the judging. So pictures would be more appropriate. Pictures of leaves, pictures of bark, pictures of flowers, if they happen to flower during the period of their assessment. They would need to catalog the abiotic characters of the, or aspects of the environment. Soil types, soil chemistry, there will be pieces in the box for that purpose. They could even map that kind of information. Soil porosity, pH, and then there are meteorology.
Weather.
I've got some on my mouth here.
Weather.
Rainfall, light conditions. They could monitor light throughout the day, get a sense of that. Temperature for sure, recording thermometer, and even wind conditions. Then they do their research project, and as we discussed, this would have to include multiple disciplines within the sciences: chemistry, physics, weather, biology, the various aspects of biology, cell and molecular, ecology, animal behavior perhaps, any of a variety of areas, evolutionary biology for sure, and conservation biology. Anyway, so they have to formulate a hypothesis that involves all three disciplines or more, and then test that hypothesis with some sort of experimental design that they've developed. Finally, they have to, obviously, they have to take that information and analyze it. Analyze it in whatever fashion they choose, but obviously they want to have statistical analysis, graphical analysis, mapping, and so on. And finally, a presentation of their results at a centralized meeting of BioBox Challenge participants. In that, they would have to provide their site catalog of the environment. They'd have to present a poster. That would be some sort of consolidation of that material. And there would then also be a team oral presentation. Okay. Next.
The teams must be made up of undergraduates, and they're enrolled at a participating college or university, and each one will have a professional mentor or faculty advisor that will work closely with the device of the implementation of the program.
And so we envision this project to get supported by partnerships through things like National Science Foundation, Nature Conservancy, or other NGOs that need the skill set that this BioBox Challenge would give students, as well as other federal and state agencies working in biology fields.
So the cost of the team would be a $500 application fee, and there's also that $500 budget coupon or allowance. So the teams would have to come up with their own $500 to spend that $500. We don't provide that.
Okay. Okay, in terms of implementation for the authority that's actually putting on the BioBox competition, the costs would be fairly significant because we're providing a box that has all of this test equipment in it, including GPS sensors. We talked about maybe motion initiated cameras, maybe an infrared device to keep track of movement within the site. So we might look for larger animal responses or activity. And all of the other materials. So we're estimating maybe up to, what were some of the other things that would be costly in there?
Well, it kind of depends on what's available. I was just going to say that one of the thoughts is that the BioBox Challenge would be a way to support institutions that might not have access to some of this equipment, or students that might not have access to their equipment. So one of the advantages to joining the BioBox Challenge is that your institution would be supported with some of this ecological supplies that can be used, perhaps in laboratories or continuing research. So we kind of see this as a challenge for students, but also as a way to give a leg up to institutions that may or may not have this accessible. And so I think it's really expansive in how much we could put in there. We want to, what we can get support for, either through grant funding or for partnership donations, perhaps from private industries like Garmin or ESRI. We could encourage them to include some of their equipment. So that's why we have kind of a little vague number. But our idea is that the box is probably worth way more than the actual application fee that the students are paying. And that's part of the kind of hook. Yeah, it's almost like a gift to the institution that participates. And I guess along that, we were a little lost on the administration and conference, and so we're going to just pass on that one to folks that are better versed in how. We know it's very hard to administer these things, but I liked your bio consortium idea of the previous group, but we kind of figured you need some administrative staff to keep track of this. So I think we'll just throw our hands up on
I'm sorry.
No,
We're just going to mention.
You can. That's
Perfect. And you can refer to the handout for a sample rubric. There just were a few different items we might rank and how things might be evaluated by the judges. First slide.
Okay, how are we going to evaluate this? Well, we have 3 phases. And so the evaluation that I'm going to read out to you, and has been passed out to some of you, is based on that same application for all 3 phases. And it's a 1 to 5 scale with 5 being excellent, clear, showing that they understand the particles as well as the connections between the particles, so that's what 5 is. And so the first one would be the optimal use of the BioBox container as a 1 to 5. So how do you delimit and use each of these tools to see something that perhaps has never been seen before? And some of the technology is quite simple. In fact, it's based on simplicity. So for the ecosystem characterization, we have optimal use of BioBox, and then secondarily, innovative and creative use of the BioBox contents. So how do you actually apply them? So some of them being simple don't direct you into a specific protocol, but you have to invent. So the device of the actual measurement, in this case, not the experimentation, will be important. Remember novelness, creativity, the imagination, as well as understanding, precision, and of course safety, rate up to 5. And then demonstrated understanding of ecosystem components. You can list everything that's there, and that's good. Those are the components. But what that does is it sets you up to ask a question of significance. And that may be based on the interactions of the components. It may be some level of organization that is much greater than the sum of the parts. So an emergent property. Creative communication of components and their connections. And remember, this goes for each phase. So being slightly adapted for the observation of the the plot observation with the experimental one. But there again, it's a 1 to 5 scale. For the applications of the scientific method then, which is the second part, they spend all that time thinking first of all, and then getting the box, and then thinking more, and then going out in the field and making observations. And right about then is almost the most precious part of the scientific method, because at that point they should be starting to see something of significance, and their educational background should prepare them to understand what is significant, and perhaps just interesting. So then the structure and clarity of the hypothesis. So the development of a hypothesis has a whole set of points allowed to it, because it's not an easy thing to do, especially if you're taking microbiology and evolution and systematics, and those are your 3 major tools. You take one hypothesis, and those will be the paradigms that you develop one hypothesis with, and you're dealing with. So that's going to be a bit of a challenge, and we look forward to giving great points for that. Then the last 5 points all deal with the ecosystem analysis, the experimental component. After that hypothesis has been generated or during it, that would be the ability of experimental design to test the hypothesis. 1 to 5. Description of experimental methods. 1 to 5. Implementation of statistics for data analysis. 1 to 5. Innovative display and communication of results that are effective, hopefully transcending but appreciating science fair level of communication. And then the interpretation and conclusions. How do the results fit into the hypothesis and the questions that generated them, and what's the big deal? So we know the scientific method goes like this. So all we're doing is we're completing one phase, and the result should hopefully come up with something that will generate perhaps next year's work.
So just to wrap up, is our timeline for this was somewhere along the semester schedule. Applications would be due in late fall some point, and the bio box would arrive sometime in January 15th, we were thinking. Students that have a chance to do their initial mapping. Their bonus box comes March 1st, and then we were trying to pick a date that would work with most schools in North America. We kind of were focusing on the U.S., but where students then have between March and July to really complete the bulk of the project, and then have the with those phases along the way where they have to report back. So I conclusion of give it to Bob to wrap up.
Well,
Wrap up.
I guess we see this as a way of getting students to work together in a science-based project, much as they have with the UROV and CANSAT, where they have to be a little bit innovative because you want to stretch what you've got in front of you to maybe come up with new methods or new techniques for looking at either your environment, your particular ecosystem, or for the scientific question that you have formulated. The other side of it is it just instills that whole concept of use of the scientific method and applying that whole process outside of the classroom.
Using the box to think outside the box.
Oh, that one.
Here is your tagline.
Using the box to think out of the box.
Nice. Good tagline.
Questions?
Yes.
Do you envision an urban campus being able to use this?
As a matter of fact, we talked about that, and there's absolutely no reason. You could even choose a street. You know, just a very long street, and look at what flows through it, how water flows through it, what sort of organisms flow in and out of it. You could certainly look at bacteria within the street. I mean, it's an
And the
ecosystem.
introduced flora and fauna, right? And people, dogs.
Yeah. Animals that cross it, feral animals, cats, whatever.
Will it be hard to judge the hypothesis part?
The question was, is it hard to judge the hypothesis part? It's a precise science of writing hypotheses, and it can be written in many different ways. And so it could be just a null hypothesis, and there's no causal effect between them. So we would actually rely on the hard science to give the criteria for judging each hypothesis. But the major thing is it testable? And then how does the experimental design flow from that? Whether it's more observations or setting up a control of variables or sets of variables.
So you guys would be judging more on like the structure of the hypothesis, not as so much as like the content?
Oh, it has to be addressing a question of significance and structural.
Structure and clarity of the hypothesis.
I think.
So you said that most of the things would be coming in the bio box, things that they could use, and then there was things that would be said by officials that they also could use. My question is like, if it's like microscopes and things, would you guys be sending microscopes, or like it's like that's in our lab, we can use that kind of thing?
Yes, and that's something that we talked about and we didn't discuss here. And that is one of the concepts is that we might allow them certain access to hard equipment that they might have on site. Whether we limit that in term, I mean, for example, if they're going to do the DNA stuff, they're going to maybe have to have a PCR machine and use it. Microscopes, absolutely. The question is, what level of microscope? You know.
So would it be like maybe, is there like I guess two questions would be, one, is a school that's more funded or well funded, do they have a particular advantage over another school? And if that's not the case, then or that is the case, how do you monitor that kind of thing?
We could just go with PCR machine and light microscopes. We were thinking about that. We don't know. At one point we said, well, if we want to develop the learning and high technology, maybe we should open up. But our first idea was just PCR and light microscopes. But it's something that we haven't got consensus on. It's a big discussion.
Actually, for myself, I would say open it up to all hardware that you have on campus. That way, if one gives the students an opportunity to access that hardware, learn how to use it, learn how to apply its usefulness. Okay. The other is that also allows those that might not have access to all of the fancy equipment a little more chance to be creative. And so you'd have to look at that and say, wow, look what these guys did with what they have. And, you know, that's certainly going to be part of sampling.
I was wondering in terms of documentation, you have like the different rubrics and stuff. Are you going to be like constantly asking them to submit information on their progress, or for each phase?
Yeah, we had said each phase, although, I mean, I would steal from that, it's not fair. I really like the blog idea and stuff like that, you know, we'll steal from other folks. But we hadn't really gotten through much then. We wanted to leave this balance between freedom, but also keeping them on track. We know how hard it is for students. So that's why our first one was, you had to have phase 1 completed by the end of April so that you're ready to go into the summer months. So I guess at phase, you know, those different phases, you'll have phase 1, you'll have like a report that you have to hand in showing what you're on, as well as the project proposal, which is actually a fairly big deal. We envision it as just a pretty broad presentation part of it.
This is kind of for both teams almost. You envision students, like if a student applied from Hawaii or from KCC, could they do this as part of a class? A whole class, and would there be enough content learned during that class that you could call that a biology class, or is this something they're going to do above and beyond their classwork?
anything.
I was thinking above and beyond just because of the integrative and most of our.
Well, I was thinking learning community. Louise in the room. You know, this is a natural learning community. But you guys too, I was thinking, you know, video.
Yeah.
Maybe there's a course, and so you could. It's an intentional learning community.
Yeah, we kind of did take from what the students were saying on when they're trying to do schoolwork, getting these kind of challenges done is difficult too, which is why we built in that kind of summer component. We kind of figured like the independent research part would actually be done more like May 15th to June 15th or June 30th. And I think we did that in part, at least I was in part response to hearing from the students, you know, I've got all these other classes going on, I don't know if I can, you know, they had most of their work was getting done during, we actually kind of were like, the first one is before spring break, right? The box comes and then you have spring break, so you can get a big chunk done over spring break, and then the next box comes and it's June, I mean the next phase comes, not the box, the next phase comes and it's more May, June, and students can do it more on, you know, I guess it depends on if they want to do it more full time or on the weekends.
And then I was thinking, like, besides the student actually learning how to use the scientific method and implementing whatever they learned in the classroom, is there any other, I guess, intent for students to apply whatever they found in this little space of land?
Well, actually, I could take some of that. We didn't really get to it. It was in our initial, I realized it wasn't really a presentation, that one of the thoughts was that since each team is working on their place right near their campus, you can start, one of the reasons the methodology is the same at the beginning of phase one is not just so we can grade or rubric score easier, but also because then you'd be building this database that you can compare between different parts of the, you know, around the country. You know, what does a site, ecosystem characterization look like in Nevada and California and Maine and Hawaii, and they would have kinds of similar components that you could then maybe build that database, and you know, maybe after a few years that could become a online part of the program. And we also were kind of hoping this might jumpstart schools to start a place, if they want to keep using that plot year after year, then that's a possibility. We're not quite sure what we were going to do with like phase two, whether they'd have to get a new plot or build on their original plot. Second year. And we kind of wiggled out of that one. We haven't quite decided. But you know, this plot could become a long-term plot that could then be used in a classroom, for example. And some of the equipment that would go to the institution after the Bio Challenge, the BioBox Challenge.
It would be an opportunity for the students to partner with, say, the Nature Conservancy or another local group. They might actually want an area categorized that they don't know what's in there. So the students could partner with them, and they could potentially have it on some of their preservation land, and it could be of value to those organizations.
But we also thought, too, we realized, well, what if you're in a city school that there's this move towards understanding urban ecology as well? And so the model would work really well if you had a Nature Conservancy land. It might work really well if you're stuck in a city park, too, because then you are actually learning about urban ecology as well. So we kind of tried to design it that if you were in any type of school system, that's why we had that 3 miles thing. We wanted also people to look at biology and ecology, not just as something you have to get on a plane and go somewhere to do, but that you can do it in your town.
I was just a little confused about how the financial part was going to work. Like, it's $5,000 entry fee and then $500 per person? Or
No. Would be like $500 for the team. That's our hope.
There's a
That's why we have to
$500
write big
application
grants.
fee.
That's for the whole team, not per person.
No, right, the whole team.
And we give 5,000.
It's a win.
So this would require
So we
grant
get
writing.
$500, you go less than $100.
Yeah.
In a good
In supplies. In supplies, and a little bit of grant for specific needs.
We haven't really, you know, we were trying, and maybe, I don't know, if you didn't complete it, you had to send it back, and, you know, if you complete the whole challenge, you get to keep it, you know, we hadn't quite.
So if I've given you $500, then you give me back $500, should I just keep it?
No, because you don't get $500, you get a $500 budget. You don't get it cash, you get $500 to
Make sure that you
spend
don't
on
spend it.
That's
equipment.
correct. We figured that a $500 entry fee would, you know, if it was free, people would just ask for it and then not even do the project.
You get a box.
You get a box and you take it home.
Well, what comes in the bonus box again? I wasn't quite sure.
Depends.
It's a surprise
It's
every
moved
year.
every year.
Like in terms of like new supplies that you can use, or
Yep. There's nothing required with it. So we send it the bonus box, and you can use it for your research.
So
You
there's no
know.
penalty points for that.
Yeah, we haven't really. Yeah, I don't know.
If you
thought
don't
about
use-
that. If you
utilize
don't use it,
the-
do you have to use it?
Yeah, you have, well, we haven't decided, obviously.
We didn't decide.
But we both put
But
it.
it's not like Rubric.
But obviously, some people will use it, and will use it in a novel way.
And I
so that's
suspect,
going to
yeah.
count for them. So in order to do
Yeah.
well in the challenge, you better think about using it.
And the next year, they'll be different. So the bonus box forced them in to do some kind of a genetic or molecular approach, maybe species interactions under the soil to be addressed here. A real sort of fine molecular. Next year will be something else.
Do you guys have restrictions on the team finding sponsors or working with local companies or?
We could not. We actually thought you should have a core team, and then if you want to add people as the semester goes. But we haven't thought about sponsors. That's part of why we were trying to constrain so that you can make it fair competition between a community college and
And sponsors would
Larger
not be
university.
sponsors in terms of funding.
maybe
Because once again,
expertise
there's
would
a
be
limit.
fine.
But help these
Expertise
teams
would be
travel.
fine, yeah.
travel funds to get to the.
Oh yeah, the travel funds.
Yes.
Yeah, that would be
For the,
good.
for the conference.
Yeah, and expertise would be fine too, like methods.
Since we're talking about funding, for Team 1, $25,000, Team 1, $25,000 is the limit, right, on your project?
Yeah.
And the team is supposed to solicit that. You're not providing it. Whereas in this case, you're providing it.
Yes.
And where is it coming from?
That's the grant we hope to write.
So we require a grant.
So that would also limit the number of teams that can enter.
Yeah, we have an application process, and I mean, like I said, maybe we have a thing where if you complete the whole challenge, you get to keep the box. If you don't complete the whole challenge, your institution is held responsible for, making sure that comes back. We haven't kind of thought that part through, but we kind of also viewed this, like I said, as a way to kind of support the whole institution towards moving towards undergraduate research, kind of support the institution with here's some skill, here's some, not only the skills, but here's some of the tools you can use to move forward, whether you do the challenge or not, or you now start incorporating in your lab.
But you could also use the Nature Conservancy money to give you money to help build the boxes. They can't tell you what's in the boxes, but if you
Yeah,
they gave you a
or maybe
donation of
like
$30,000
Garmin might give
to
a
make
box,
the boxes with their money.
Garmin might donate the box, and
Yeah.
maybe some of the DNA companies would donate some of the stuff. I mean, that's why we left we kind of said we think it would be somewhere, we're kind of hoping we could fill the box with hopefully as much as we could,
Depending on what they give.
depending on what we could figure.
And it might not be $5,000. It might be $1,500. And the other thing is we might be able to give them instructions on how to build something, and that they can go out and buy the parts with their $500 expense account and build it.
Would it be possible to have the entrance fee cover materials?
It could be, but we kind of, like I said, we wanted to have it be more supportive than, but that was just kind of our take on thing about it. We wanted to support the research, not make it a barrier. But that's this whole concept of getting someone else to pay for it, the grant writing, rather than having the students pay for all this stuff. Because we understand a lot of the equipment can be expensive, and that's part of one of the barriers, we think, for undergraduate research.
Did you guys mention like the minimum size of your team, or did it just like be one person?
No, we did. We kind of talked. We said I think a minimum of like 5 or 6 in the initial application. We almost had a max at one point. We were a little vague on that one.
It's true, was aiming for 10 at one time.
Yeah, we were aiming for around 5 to 10 students.
We kind of left it open so that we would be money. So if it ended up being a huge thing, that would be the case. But there's still, in the reporting, you have to see evidence of cooperation and problem solving and involvement and cooperativity. So those, of course, would be different challenges. It's a huge group of time. So we left it open. And our last decision was to be decided.
set?
Max up.
Max?
Max.
I don't know what the minimum is.
That's for official team members. But you can have more than
Oh, you can.
There's only 10 official.
So that was kind of like, you wanted to make, if you wanted to bring students on over the semester, maybe that's how you do it as an
I
unofficial.
think that more people can even attend. It's just, there's like 10 people that
On the issue of team composition, is there a mentor, like a grad mentor built into the team, or do you provide it, or?
Well,
I thought that was up there, but maybe we didn't mention it.
Maybe I missed it.
Either a faculty advisor or professional with a mentor.
Oh, maybe I didn't see that.
As an event, you were asking, as an event, are we gonna provide a mentor, like the way?
Well, the team has to prove that they've got a mentor as part of their application.
Yeah, that was.
And we also saw some advising on the side of the BioBox challenge and staff, because they have to give that proposal presentation, and that's kind of the chance to vet whether that's doable research in the amount of time that's allotted. And, you know, so there would have to be some folks on the admin, or at least on the partnership side, that were willing to review proposals from students, which isn't a small task. But we think it's really a critical part of getting through an independent research project is presenting your proposal and having to think it through and getting evaluated.
Okay.
Okay, thank you. I think the two teams can go talk to each other for a while and have some cookies and coffee and
Can we
a glass
present
of
you with our
water.
our final reports?
What?
Can we present you with our final reports?
You want our written report.
You want our give them to the
Yes, we want it, and we want it also in La Lima, so we want it.
Well, we know that,
and
but
put
like
it in-
now, there's all
give
kinds
it to
of
them.
stuff in here.
copy.
We only have one copy, but
They can pass them. You guys can start saying what you think generally, and then we'll come in with the numbers in a sec.
I guess it's over here. Oh, this way. First of all, Pestis, I really like it. I think initially I didn't quite understand what the mission. I started to get it towards the end. But I was thinking it's a really great idea to then bridge the gap between different kinds of disciplines, so from science to art, even, or even getting the science students open to opening up their minds to creative ideas, being able to edit videos and whatnot. And I was thinking of maybe, to addition to your competition, maybe possible awards for these students. So maybe there's a best film category or best documentary.
I'm sure we could have gone there.
Right. So, and maybe the winning team gets put on a 30-minute spot on a local TV station on like a whatever night, And then again, there could be best presentation, best idea, or best implementation kind of thing. So just some feedback that I thought would be really helpful. I like the bio box a lot. I think it's definitely, I think it's more geared for undergraduate and also community college students, because it doesn't leave too many things up in the air of what I should do. I'm sitting here now with an entire lab and I got no idea. I think it might be easier to motivate the students to think about hypothesis, something like that. I would say the $500 is still expensive for the team, because even right now on the RV project, we do spend things out of pocket, and John's not supposed to know that, the others heard that. But the fact of the matter is that it does happen, but it's really bad, and just being students of finances are at an all-time minimal level for most of our college careers, and I think if finding somehow to maybe if you can get somebody to get their schools to pay that $500 entry fee, and then the school again would be held accountable for the parts if they didn't finish the project, or if they didn't win or something like that. But other than that, I really like the idea, and I think that you could get some recognition for something like that. It's pretty well thought out.
I like the bio box. I like both ideas. I think the bio box is really good. I think it'd be like better implementation if it was done to a class specifically. Because I mean, just from a student standpoint, it didn't pique my interest as much as like the eradication one did. But just because I'm a high box, I'm not biased now. I think it's great to learn like steps of what you're supposed to do because again, sometimes in lab you don't get that. And I think it's really a good thing to do. I think it's good how you get like MacGyver stuff and like what you're given. I think that's great. I'm a fan of that. Yeah, it's really cool. The test is, I think it was a good idea to mix the interdisciplinary. I thought it was good. You have like your micro and you have your eco. I thought that was really cool. And yeah, the video I think is a good idea if you instead of like marketing, you have your tech report for your scientists and have like your marketing for like the public, general public. I thought that was a really good idea too. I think they're both really good. Using a lot of things.
I like the ideas too. I like the bio box because it kind of allows you to like dream and kind of just really get into what being a scientist is, as opposed to, oh, you're gonna work on eradication. What if I wanted to work on a global climate change? That was one thing I really liked about it. Testes is pretty cool though. It really is pretty awesome because that's a big thing. I thought you'd probably be able to do like more public relations and set up like contacts with people with testes as opposed to like a bio box. I just feel like you kind of get stuck inside the box too, the bio box. Just going out and making contacts with other people. It's kind of limited. Though yeah, I just like one little area where maybe testes would allow students to like travel farther, out of their area. But it's good. I like their presentation from bio box. That was really good.
I like both of them. They're very creative. For me, the bio box seemed very simplistic, but doable within like a semester or so time frame. So I like that because it was easy to do, and you could balance that with your full workload of classes and stuff. But for me, I felt like some components were kind of missing, like I guess the details and like how you would go about. I don't know, maybe it's just me being all structured, but just more guidelines, I guess. But I thought it was creative, like it lets you be creative. For the testis, I thought it was good because it opens up the whole world to this activity or possibility, because you can get people from all over the world to participate. And I like the fact that you can communicate across oceans and stuff like that. I did think you could allow yourself to get so engrossed in it that you kind of, like, I guess, bite more than you can chew, because you could be like, oh, I want to explore this, and then like start getting into it, you're like, oh man, that's a really big project, I was looking at the time. I was looking at the time frames though, because we said like you're gonna submit your proposals in October, the 1st of October, and then you present next year on the 15th of October. So I thought that might be difficult for someone who might be interested in doing a different project within the next year, because you have to do a proposal as well as your conclusion within the same month of like 2 weeks.
Oh yeah, I wasn't looking like I would have to think about that.
Yeah.
The like year after year thing.
Because if you wanted to continue, I mean, I guess you could modify the one that you were working on, but
I
if you
didn't want to
wanted
just make one later.
yeah, to a whole new subject, that would be kind of stressful. So that's, but I like both of them. They're very both creative, very different views.
Just to give you guys the mean of the student scores, bio box 83.25 and testis 79.44. So they're only like 4 points apart. The bio box won by 4 points, which is really close. So that was an average. That was just students. We kind of divided the groups because we thought that the perceptions might be different because they're coming from different, different perspectives. So, thank you guys. Good. Okay, thank you.
Thank you guys.
Yeah, thank you. Good luck with your robots.
If you guys want to go, unless you want to hear the feedback.
I would. Yeah.
Wow, it's hard to add to what the students have described. They did a great job. I guess the only thing I would say is that I think the test is much broader and perhaps because it's more flexible in the kinds of things that we can do with these that it may, and I think some of the students already expressed this, that it may be more difficult to do perhaps. Whereas the bio box is much more prescribed. You're doing things with whatever you can do with that box. You want to encourage them to think outside the box and start using each of the tools. But nonetheless, it's very much prescribed. So those are sort of two differences. But again, from a personal perspective, the test this project probably gives more opportunity for, like I said, the word transdisciplinary approach to understand the science of biology, and including more subdisciplines of biology that might be probably could, but I think the best case allows broader integration and transdisciplinary approach.
Just to address your question, I guess, I would anticipate that the teams that would participate would be ones that have some sort of a transfer degree. They might, in other words, they're not just taking Bio 101. They're going to be...
I'm not familiar with like the other campuses. For example, Windward, would they be as strong in the biological biology area? Leeward, I think, yeah. Yeah, he could do that, but I don't know what per se.
Yeah, Dave knows. Dave knows molecular biology. But I think it would be cool if they didn't. They'd have to go see maybe an industry partner or something, which could be a cool thing.
Yeah, no, that's
I like to guys
really fast.
For me, I like a lot the business idea, like two types of format, the writing at the end, and the flexibility to our students to use the types of data and overall that. One thing that's common to both things, which I've noticed always has to be inside, is the time management. That's the hardest part of this. From today until the next month, their average sleep time per day is going to go up to 2. That's what it's always interesting. So I thought it would be nice to have something similar to NSAT, which has implemented the idea of everything can be done every 2 months. And allocate all this based on this type of biology. So you have a team towards some report with specific guidelines, and the mentors from the organization would give feedback to the students. And the CPR would be how the students have fixed all the stuff they don't feedback they have from the previous one, and get better and get better. But the idea of having every month, every 2 months, is something more to 20, that they learn, the time management. We have this task to establish, we try to get into this stage, or this month will be for this. So to me, that's very, very complicated. Because if the project is involving instructional capacity, they're great. That's a good problem. The project, yes, of course, get it done, right? That's the thing. But if I can allow you to learn this successful.
And that way I gave that you guys incorporated the fact that yes, they have to really get schools push it into the summer. But that was excellent.
Just so you know, the faculty means are Pestis 1, 90 points, 90.1 points to 84 BioBox. So students chose BioBox over Pestis, and the faculty chose Pestis over BioBox. It's very-
You were close.
So, and all of it very close. So I guess it's two winners. Yeah.
And we will Xerox these things, and we need to give some of them to Corral, because today they told us they want a Xerox of these sheets, and also we'll Xerox for each team and put them in your team book. I know we're trying to cut paper. A few things like this are good records, especially I think you'd want to read what the comments are.
Maybe we can scan them and upload them to Lavi.
There we go.
Okay.
I like that idea.
So Judy, do you want to talk about the prize?
I do.
Prizes, two
Prizes.
winners.
These are your prizes for the year, and each team gets a set of clickers. Each team a set of clickers, because already one of you said, I'd like to start with clickers on Monday. Let's start with clickers. And you're going to have to share them for a year until you figure out whether you're going to require students to buy them. Kathy wants to use them in summer and with the summer bridge kids. So they're going to be kept in that top file. Is that okay? And you come in here and you get them, and maybe you should write little notes saying, you know, Mackenzie's got them and the date, or make some kind of sheet so that each team can use them in the summer. And you know, maybe that doesn't thrill some of you, but others of you, I think you'll probably get the hang of it. If you need any clicker lessons, see me and I'll help you get it started.
Good job for all of you guys.
Each set has 35 clickers, so that should cover your students. And then it has one receiver, it has the software in there, but you might want to download the latest version of the software from the web. turningtechnologies.com.
Okay. Do you guys as teams want to comment at all on the process, the teamwork, the content, the structure of the activity? Any feedback?
Well, we'll be surveyed tomorrow.
Well, just sort of off the top of your
Yeah,
head.
while you're sitting there. What'd you think? You had about 8 hours, I think.
Go ahead, Mama.
Well, I think our team really worked well. We first brainstormed what we're going to work on. The first time we were going to think about everything else. And then we sort of had an idea of what to work. Then we came back to Bombing Day. Then we just said, okay, we'll do this. And as we were working on it, our ideas were evolving. We thought methodologies were also evolving. And each of us putting our individual strength into the work that we have, like Kim's doing editing, Maddie's doing working everything together, and Kim's very good at looking at all the school kids, we all work together.
It's interesting you're mentioning skills that have nothing to do with botany or engineering or bio, but the soft skills. That's interesting.
We were paired well in biology too, and all four of us are.
Cool. How about you guys?
Well, I'd say we had a similar experience. The first day, we kind of walked away with an idea that we kind of cogitated on overnight and came in to expand on the next day. And I think we kind of went from there. There were a lot of barriers to kind of overcome and in terms of how it would play out. And there were are still some big question marks for sure, but we will pretty much, rather than separating the group and doing individual tasks, we pretty much did it cooperatively.
So you didn't delegate really, you just kind of stayed together.
Yeah, for the most part.
That's really
We did it very
interesting.
different.
Because you guys were all like at your computers really quiet and I couldn't even tell you were in there. I'd go in and you're all working on your tasks and you guys were always like milling about and standing up and really different work styles. It's really
That's
interesting.
And then we just send all our data into one computer and different records.
We were Google Docking, so live editing. That's why we were working in silos. It reminded me, you know what, I thought it was kind of cool because it was like, when you read an RFP and you go through like what the requirements are and what they want, basically that's what we were kind of creating, it felt like, and it was just hilarious because I've not written many grants, but I had a NOAA grant last summer that I put a proposal together for, and it was so frustrating because the language is just so fluffy and out there, and I'm like, what do they mean? So it was interesting to be on the other side of that, be like, I be concise and clear, so that, you know, if those teams want to put this together, they know what we're talking about. Like, it was a cool experience in that regards, for sure.
I liked your 30-minute limit on your phone. Even though some people said, can you get it all into 30 minutes? You can get an amazing amount of stuff into 2 minutes. And for some people, 2 minutes is, so I thought 30 minutes and document over time and, you know, maybe you would keep an audience paying attention in the film festival approach. A film festival on invasive species, has that been done before? I don't think so. Not enough film. Can we? No.
I think that from my perspective, I was thinking in terms of grants, and both of them are infinitely fundable. I think the film festival is definitely something you could take to broaden participation groups and say, you know, this is something we really want to do because, you know, there's so much transdisciplinary. I'm thinking Waianae High School and all the stuff that they do that in Hawaii alone, but you know, that's huge. And then, so I think I would think that these groups at NSF would really love something like that because what's nice about it is you have a product in the end, which is a bunch of videos, right? Which then they could take and edit and make a single output for NSF. It's the broadening impact. Is huge for Congress and all. I can just see them going, this is way cool. And it's biologists too, who you don't think of as doing this kind of outward stuff oftentimes, because you guys work in labs and do your thing. This really telling the story big time. But the box, the bio box, is FIRST Robotics. You got a state that's committed to FIRST Robotics and they're throwing all this money at it. And now you got a group that's saying, you know, we got a project that's very similar in terms of the box part. I don't know if you even know about FIRST Robotics. FIRST Robotics, you basically have to build a robot. They tell you the competition, and then they give you a box of parts, and you got to build it out of that box. Extremely cool the way they do it, but it sounds very similar to what you kind of came up with. And then I'm thinking, we got like $30 million in EP score that's concentrated on environmental sciences, ecology. EP score can put this together, and this is here's an opportunity for that group that wants to work on broadening participation and all. Here's a perfect activity that they could work on. And then they could invite other EP score states to do this. It could be, I could see how you could implant that right there. And they could probably do it with the money that they have in-house. It'd be perfect. So I think both these are huge potential.
That's why you both got tried.
Yeah, so if you wanted to follow up any more on them, I'd be happy to work on them too with you and see if we could figure out how to make them into models that we could then go and site this out wherever presented to NSF or take it to the expo people and say, this is something we want to think we've had the same experience with that.
Implementation's always a lot harder than figuring things out. And so over the summer, I think that this fire up group is gonna have to think long and hard about your place and some of the things you're going to be implementing and some of the things you just can't work in this year, but maybe next year. And I think that one of the things we've discovered too is a need to get together a little more often in real life, not just in email. And so you have to find mutually acceptable times once or twice a month where we get together and we have, you know, Kapiolani or go out for wine and beer and kind of, or whatever, and talk about these things. Have a barbecue at John's house.
Oh, volunteer John's house.
And we're always barbecue at John's.
Volunteer John's